Welcome back to the channel. Hope everybody's doing well, and in today's video we're taking a second look at the resistance, capacitance and inductance measurements on this revision 8 of the DMM CheckPlus. When I made the previous measurements, I couldn't get them quite within spec. Some of that appears to be due to the way I made the measurements, so I'm going to repeat the measurements and see if we can get them any better. I've also done some more work on the actual tolerances to see where they should fit in with the specifications of these instruments. So our biggest concern was with the Keithley and the measurement of the 100 ohm resistor, because that was out of spec. When I made this measurement originally, I did it on 2-wire, and I neglected to null the leads out on this. We'll turn it up to 5 PLC, so this will start again towards its more accuracy. When up the PLC specification, I reduced the RMS noise, or the uncertainty from the RS noise within the unit, so we always turn it up to do that to get the best measurement. We're on auto 0, but I'm going to short the leads together, as we see there, and we're going to rel it out. And we've got a pretty good 0 there, and we'll try it again with our 100 ohm resistor. Now we are now 100.01343-ish. So to work out all the way through the calculations, this instrument should be displaying somewhere between 99.9952 to 100.0088. So we're still a little bit high. However, you have to read the small print that comes with the accuracy specifications. So for 2-wire measurement mode with rel on, as you see there, you have to add an extra 50 milliohms to the resistance value. So if I add 50 milliohms to the 100.0088, that reading is now within spec. So that all appears to be good. I'll just quickly whip through the other values as well. That's the 1 kilo ohm. Obviously, as we go higher, the 50 milliohm additional uncertainty becomes less of an issue. And they are all looking to be good at this moment in time. I'll put these in a chart at the end again, so you can see 99.91. Yeah, it should be 99.52. So that's all good. That's within specification as well. No problems. Now, when I looked on the website for the DMM CheckPlus, it actually stated that the resistance measurements that's done with their HB3458A is actually done in 4-wire mode. So there's the second boo-boo that I made as well. So if we turn this into 4-wire mode, and I need to remove that because that will be different. Now we'll short them out. And we'll put on relative mode as well. And we'll just whip through these on 4-wire mode and see what values we get. 100.0249, which is, see, that's worse than the 2-wire measurement now. Let's go up to the 1 kilo ohm. That's all looking good. 10k. Yeah, that's looking good as well. And then finally our 100k. 99.91. Yeah, that's all. I think that's all looking good. So okay, resistance wise, 2-wire are okay. 4-wire I'll have to go back and check what the actual tolerance value should be. It does still appear to be a little bit high on that 100 ohms for some reason. Not sure why. So the other issue I had is with the capacitance measurements on this Keithley. I said I wasn't too concerned because I wasn't that sure of the signal that came out of this and whether that matched what DMM CheckPlus tested the components at. We've got the frequency counter set up, reading the signal from the Keithley here. We're set to capacitance on the Keithley and we are actually reading 8 Hertz signal, which seems incredibly low. And they were 10 kilohertz measurement signal for the DMM CheckPlus, so that will be explanation as to why the readings were out on the Keithley. So I'm not too concerned about that capacitance measurement, it kind of explains that. So just quickly swapped over onto the oscilloscope and you can see here we've got 2.84 volts peak to peak and we are 88 Hertz, period is 11 milliseconds, pulse width is 360 microseconds, which is completely different to a 10 kilohertz signal. I will just put the clip back on so we're actually measuring a capacitance value now, and you can see it drops to 86 Hertz, but doesn't change appreciably. So that's probably the reason why I'm getting some of the inaccuracies measuring the capacitance on the Keithley there. So for comparison, I'm just going to go through with the Anbai 802817A again and just repeat these measurements. I've checked all this out, frequency is okay, speed setting affects the accuracy, it's set to slow, which is its slowest, so not much else I can do as far as I'm aware with this one. That's the slowest it goes, so we'll have to leave that as it is. We're set to 10 kilohertz, which is the same as the CERT. That's the reading that we've got for the 1 nanofarad capacitor. Let's step him up. There's our 10 nanofarad, which looks to be pretty good actually. There's our 100 nanofarad, and finally our 1 microfarad. That's them there. And we'll just flip him around and look at the inductances. So these go the opposite way. So we are 1 microhenry here, and we need to change to so there's our 1 microhenry. Go to 10 microhenry. We'll go to 100. Gets a little bit out, I think, 1 millihenry. There's that value there. Okay, so since we didn't have too much success with the Anbai 802817A, I've hauled in this Voltcraft LCR 300 to see how we get on with that. This is just finishing off its calibration. When that's done, we'll look through the measurements with this and see what kind of values we get there. So that's all okay. Set this to, let's do our capacitance first. That's capacitance, there's serial, we're at 10 kilohertz. So let's go through these. This is our 1 nanofarad, and we're 63 picos. Move to our 10 nanofarad, 10.15. Move to our 100 nanofarad. And finally our 1 microfarad. Okay, that's all those measurements there. We'll flip him round and we need to go back to inductance. Serial inductance, we start at this end. So this should be our 1 microhenry. That's quite low, isn't it? Be 10 microhenries. That's not too bad. We'll get 100 microhenries. And finally our 1 millihenry. And then again I'll put all these through the computer and see how we get on in terms of accuracy. Well, we'll just do actually. Let's put through these resistors whilst we're here. See what we get on with this one. Ooh, that's different to the DMM7510. Let's go 1 kilo ohm. Bad. 10 kilo ohm. And then finally our 100 kilo ohm. Okay, so that's all those measurements done. Back to the computer we go and see how the results are getting along. So here's our results screen. If we take a look at the top table, which is for the revision 8 version, the nominal value is on the very left hand column there, and then that first set of 6 columns are for the DMM7510. We've got the range for the expected results, and then for the 2-wire mode we've got all 4 resistance readings are within specification, but that 100 ohm resistance reading is predominantly because of the additional 50 milliohm that we need to add for the 2-wire function. So our 100.0088 maximum is actually 100.0588, which obviously the 2-wire reading now becomes in specification. Although interestingly, if you add 50 milliohms to the minimum value, that then goes above the reading I obtained as well. So it's how you interpret the addition of that 50 milliohm value really. That seems a bit too convenient for my liking. But anyway, on the 4-wire mode, our top 3 resistances are all in spec, but that 100 ohm isn't in spec. 100.0249, because we don't get the 50 milliohm concession with that. So it looks like there is some sort of an issue around that 100 ohm reading at this moment in time. The next set of 6 columns are for the AT2817A, our bench LCR meter. Same principle with the min maximum values. The reading at 10 gigahertz and then the reading at 100 hertz. We've got pretty tough time at 10 kilohertz. There's not much in spec there at all really. A little bit better with the 100 hertz with regards to the resistance values, but for both settings the inductor readings are all out of specification. Now the tolerance I'm getting for this AT2817A is just a spec 0.05%, so that value there to me doesn't seem a very good specification. A lot of the instruments, they have a specification based around the frequency setting that you use on these LCR meters, but this doesn't have that specification, so I'm a bit dubious as to how representative that 0.05% really is. Yeah, I don't know. Let's move over onto the end. The Voltcraft LCR-300. It's given me the best set of readings out of all of them really, especially at 100 hertz. 100 hertz I can get all the resistance and the capacitance bar 1 in spec. The main issue just appears to be around those values of inductance really, which are problematic across both the instruments. And oddly enough, just below this table I've put the prices down, so our £120 LCR-300 has given me the best set of results so far, but that does have a wider accuracy range, so that will be part of that really. So if we just go back to the DMM7510 at the very bottom here on the left hand side, I've done the same comparison for the 100 ohm resistance value on the revision 5, and that's also out of tolerance as well, 0.0201%. Now I didn't put the percentage on the revision 8, but that actually calculated as 0.0229%, so it's out by a comparable amount across both of these CheckPlus units. So yeah, again it's pointing towards an issue with that 100 ohm range on the DMM7510 unfortunately. And that could be a expensive because I think that has to go back to Germany for calibration. I don't think that can be done in the UK. But I did look at the last UCAS calibration that I had on this, which is just purely checking the values. They don't adjust it if it's out, whereas the manufacturer will adjust. And in actual fact, our 100 ohm reading was within tolerance. So don't know what to make of that really. I've obviously got a little bit more work to do with regard to that. I do have a 100 ohm calibration standard coming to me. I found one on eBay, so that's making its way to me, and we'll see what kind of readings I get with that and what else I can compare it to as well. But I think that's something that will go into the to-do pile. So that'll be it for this video. Thanks very much for watching. I hope you found it useful, and I will see you again in the next one.